Have you ever wondered how groundbreaking theories evolved into the experimental marvels of quantum computing and photonics? Today, we journey through a curated collection of academic milestones that laid the foundation for modern quantum research. This exploration begins with the pioneering theories put forth by early visionaries, whose work set the stage for a revolution in how we understand computation at the quantum level. In the late 20th and early 21st centuries, scholars like DiVincenzo and Rossendorf were already charting new territory. DiVincenzo's work on the physical implementation of quantum computation opened our eyes to the possibility of harnessing quantum mechanics. At the same time, Rossendorf and Briegel introduced the one-way quantum computer, reshaping our perspective on information processing. These studies were far more than theoretical speculations. They posed real challenges that researchers needed to overcome if the quantum future was to become a reality. The early theoretical hurdles, marked by uncertainties and experimental limitations, sparked a wave of innovation. As debates raged in academic corridors, scientists moved beyond the initial concepts towards experimental breakthroughs. For instance, significant advances in photonic systems began to emerge, as researchers successfully generated entangled multiphoton states that could be manipulated for quantum networking. This transition from theory to practice was not immediate. It required experiments that demonstrated the feasibility of intricate quantum phenomena, such as photon entanglement and cluster state generation. Visualizing this evolution, imagine laboratory setups where atoms and photons work together in harmony, forming complex networks that mimic the fundamental processes of computation. The experimental work brought us closer to achieving practical quantum communication systems. Studies detailing the deterministic generation of quantum repeaters from solid-state emitters underscored the potential for near-future quantum networks. With each new experimental method, the challenges of realizing a true quantum internet were met with innovative solutions. Among these advances, the exploration of quantum dots and single photon sources holds a special place. These tiny structures have proven to be critical in controlling and manipulating light at the quantum level. The development of high-fidelity, indistinguishable photon generation systems has paved the way for more stable and scalable quantum devices. Researchers have fine-tuned these systems, working tirelessly to enhance spin coherence and electrical resonance. Such meticulous studies indicate that even the subtlest quantum interactions can be harnessed for practical applications. This narrative of progress is not simply a timeline, but a testament to human curiosity and persistence. Challenges in early quantum research were met with profound breakthroughs, such as advances in spin qubit manipulation and the realization of coherent multiphoton states. As experiments grew in sophistication, they bridged the gap between the idealized concepts of theoretical physics and the tangible realities of laboratory research. Every reference in this collection represents a stepping stone, from the meticulous bibliographic entries of foundational theories to the detailed accounts of experimental innovations. Discover how quantum repeaters and photonic fusion techniques have reshaped our understanding of entangled systems, and appreciate the rigorous methodologies that turn theoretical proposals into operable technologies. In this narrative of scientific progress, we see the compelling interplay between abstract theory and concrete experimentation. The evolution of quantum research, spanning over decades, illustrates a relentless drive to push the boundaries of what is possible. The collection not only highlights seminal works but also invites us to recognize the cumulative effort of generations of researchers who dared to ask critical questions and pioneer new techniques. As you watch these visual depictions and reference lists, allow yourself to be inspired by the intricate tapestry of discovery and innovation. This academic journey through quantum computing and photonics provides a detailed account that bridges historical context with modern technological breakthroughs. Embrace this exploration and share in the excitement of quantum science evolving before our eyes. Download the full list of references for an in-depth study of quantum computing and photonics research.